Now we will do another application on working out the area between a curve and a straight line. Look at this example. The diagram shows a sketch of part of the curve with equation y equals x squared plus 1. So we have a parabolic curve, and the line with equation y equals 7 minus x. So we have a curve and a straight line. The finite region R1 is bounded by the line and the curve. It is very important to pay attention to the word finite. Finite means that we have a limited region. For the straight line and the curve, we have two regions available. It is either this part or the part here. We know that the curve continues to infinity, so we cannot know where it ends. That means here we have an area that we cannot calculate. That is why we will take this region, which is the area between the curve and the straight line. Let's continue. The finite region R2 is below the curve and the line is bounded by the positive x and y axes as shown in the diagram. R2 is between the curve, straight line, x-axis and y-axis. In part A, we need to find the area of R1. R1 is the region between the straight line and the curve. That is why we need to know the limits of x, so where these two curves intersect. Thus, before calculating the area, we need to obtain the intersection of the curve with the straight line. We set y of curve to equal to y of straight line. The equation of the curve is x squared plus 1 equals the equation of the straight line, which is 7 minus x. Let's organize the equation. X squared plus x plus 1 minus 7 equals to 0. X squared plus x minus 6, because we have plus 1 minus 7, equals to 0. Now we search for factors such that their multiplication will result in minus 6 and their addition is plus 1. The factors are x plus 3 and x minus 2 is equal to 0, because plus 3 times minus 2 is minus 6, plus 3 minus 2 is plus 1. So, x plus 3 equals to 0 or x minus 2 equals to 0. For the first one, x is minus 3. So it is on the negative side. This is point minus 3. Or x is plus 2, so on the positive side, this is plus 2. Now we found the intersection points. Okay, now for the odd one. It is the region between the curve and the straight line. And we already calculated the limits here. This is minus 3 and this is plus 2. As you can see, the equation of the straight line is higher than the equation of the curve. So the equation of the straight line is y1 and the equation of the curve is y2. Area of R1 is integral y1 minus y2 dx, where x starts at minus 3 and ends at plus 2. Okay, integral from minus 3 to plus 2, y1 is 7 minus x minus y2, which is x squared plus 1. We put it in parentheses, dx. Okay, let's organize it. Here we have from minus 3 to 2, 7 minus x. We multiply the minus inside the parentheses, so minus x squared minus 1 dx. Let's continue. Integral from minus 3 to 2, minus x squared minus x plus 7 minus 1 is minus 6 dx. Now we will do the integration. Minus x cubed over 3 minus x squared over 2 plus 6x. It starts at minus 3 and ends at 2. Now we need to substitute the values. We will start with the 2. Minus 2 cubed over 3 minus 2 squared over 2 plus 6 times 2. Minus, now for the lower limit, which is minus 3. we have minus 3 cubed, so plus 3 cubed over 3. Minus, when we put minus 3 instead of x and we have power 2, it will be 3 squared over 2. And then we have 6 times minus 3. We do the normal calculations. Minus 2 cubed over 3 is minus 8 over 3. Minus 2 squared over 2 is 4 divided by 2, so 2, plus 6 times 2 is 12. Minus. Now for the second part. 3 cubed over 3 is 9. Minus 3 squared over 2 is 9 over 2. Plus 6 times minus 3 is minus 18. We continue solving normally. Minus 8 over 3 plus 10 minus 9 over 2. Okay, so minus 8 over 3 plus 10. Minus times minus is plus, so plus 9 over 2. Okay, so minus 8 over 3 plus 9 over 2 plus 19. We take a common denominator, which is 6. You can use the calculator to solve this. We will have minus 16 plus 27 plus 114 over 6. The final value is 125 over 6. We can simplify it is 20 and 5 over 6 as a compound fraction. As you can see, it is the same concept that we solved previously, but it was longer because we solved for two limits. Usually one of the limits is 0 and we ignore it, but here we solved for two limits. In the next tutorial, we will solve for the finite region R2.